Ladies and gentlemen, welcome to the Triune Physics, aka Physics Bible. Today we are going to be considering conservation of linear momentum. This will be purely physics. In our next episode, we are going to connect it to biblical terms for better understanding. Is that clear? So when you say conservation of linear momentum, in other words, it means the principle or the law of conservation of linear momentum. The principle, which is the law of conservation of linear momentum. So we are going to state the law vividly and then we explain. Is that clear? Now, when you hear about this law, two things will come to mind. The first, in an isolated system, okay, of colliding bodies, collision is very important here. Total momentum is always constant. In other words, it means conserved. Is that clear? Or the second, we can say or paraphrase this law to be if two or more bodies, collide in a closed or isolated system, then what will happen? The total momentum before impact, that is initial, equals the total momentum after impact, which is final. Is that clear? So, if we explain this principle, you understand that a closed system or isolated system is a system on which no external force acts on. Is that clear? Neither does itself act on another body or system. So it's just like someone is isolated or a particle or a body is isolated. Let's highlight the most important concept here. We have isolated system, we have colliding bodies, and then we have total momentum. Is that clear? Let's also highlight from the second. You see two or more bodies, the triune components. Number one, the bodies, very important. Is that clear? Then you can see collision. They have to collide. And when these two bodies or more collide, then the total momentum before impact will equal total momentum after impact. So please take note of the word before and after. Exactly. They signifies initial and final. Is that clear? Please understand this concept. This has to do with two bodies hitting each other, colliding with each other. For example, when accidents occur between two moving vehicles. I hope you understand this concept based on that. So let's express this mathematically. Mathematical expression, okay? Mathematical expression of the conservation of linear momentum. Are we here? That law can be expressed mathematically. So let's do that, because when you have problems, you need to solve them. All together, conservation of linear momentum, okay, can be expressed in four ways. So this mathematical expression, I'm going to do that in four ways, please. Okay, so that if your problem come in any of these ways or in any of these terms, you will be able to solve your problem based on the expression. used. So the first, let's begin with the first now. Let's imagine that two bodies, okay? Two bodies moves in the same direction, before and after collision. That's initial and final. They move in the same direction. Then what will happen to the mathematical expression, the symbols? Everything will become positive. Is that clear? Both the left hand side and the right hand side becomes positive. Please take note of this as we begin to solve. Now, if this is our first body, a second body, let's repeat the two again. Let's repeat these two bodies. We want to denote or represent this collision. So I have the first body, I have the second body. You can see the arrows pointing in the same direction or towards the same direction. Then let's repeat the same objects, the first and the second, okay? The arrows now, observe, pointing towards the same direction also. All together. If this is your plane surface, then if this is the M1 and M2, then we will have our U1, okay? And then we'll have our U2. Is that clear? Signifying initial. Then M1 and M2 repeated, the same bodies will now have V1 and V2. Is that clear? It is the rate of motion that will change. Is that clear? Then this first part by your left hand side before collision, and then by your right before collision for M2. Then M1 and M2 after collision. Their movements after collision, after they hit each other. Is that clear? Then both of them will move in the same direction. I hope you are following this, please. Now, let's express this mathematically. So we can remember from linear momentum that, okay, that P is equal to mv, right? Mass multiplied by the change in velocity. All together. Now, if this velocity can be expressed alongside momentum with mass, then we have our initial momentum to be mu. Is that clear? Then final momentum will equal mv. Okay? Now, if we unite these with this idea between two bodies, then we can express this diagram as m1 u1 plus m2 u2. Is that clear? We equal m1 v1, okay, plus m2 v2 all together. Now look at the diagram. You will see that we're having positive sign. The reason is because they are both moving in the same direction. Are you getting that? The same direction, you have positive sign. Opposite direction, you have negative sign. Is that clear? Please take note. This is our first representation of the mathematical expression. Then the second representation, if M1 and M2, okay, and M2 moves in this opposite direction. If both M1 and M2 moves in opposite direction, okay, before collision, and the same direction after collision. Recall, M1 and M2 moves in the opposite direction before collision, then the same direction after collision. Then let's represent M1 and M2. We duplicate that. Is that clear? Then let's represent the direction of motion. Are we here? Hope you are getting this part. This M1, M2, M1, M2. Is that clear? Then U1, U2, then V1, V2. Can you see this? Now, we want to represent this mathematically. So please observe your arrows. Is that clear? Recall or remember that the same direction, positive sign, opposite direction, negative sign. Then M1, U1, okay, minus, are you getting that? M2, U2 is equal to M1, V1 plus, we're going to have plus M2, V2. I hope we get these. The reason is because they are moving in the same direction. Okay, so the first part by left hand side signifies the opposite direction, and the other part is the same direction. Exactly. Then the left hand side signifies initial, and the second part final. I hope this is clear. So let's proceed further to the third expression. If M1 and M2 both moves in opposite direction, okay, in the opposite direction before and after collision, opposite direction before collision, opposite direction after collision, then let's represent this using diagrams. Okay, our M1, our M2, our M1, our M2 repeated. Okay, direction, direction, opposite, opposite, opposite. Are we here? Then we have M1, M2, U1, U2. Then M1, M2, V1, V2. Is that clear? Then let's express this. This is collision now. Let's use mathematical symbols to represent this. If this is our surface, then we can have before collision for M2, then M1 and M2 after collision. Are we here? Please take note of these expressions because they are very important while solving problems. So M1 U1 minus M2 U2 is equal to M1 V1 minus M2 V2. I hope this is clear to you. So take note of this equation. Is that clear? Then the first part is before collision. The second part is after collision. Is that clear? Then the negative sign signifies opposite direction. The negative sign also signifies opposite direction. I hope that is clear. Please check the arrow. You see what it depicts or means. Please, I hope you are following. I hope you understood this concept. Is that clear? Now, opposite direction. Now, the fourth and the last. If M1 and M2 moves in the same direction, okay, moves in the same direction and before collision and opposite direction after collision, then what will happen to our equation? Let's draw this M1, M2, okay? Let's repeat them. M1 and M2, we are going to draw the same diagram, the same bodies. Is that clear? All right. Then our arrowhead, can you see what is happening? They are both moving towards the same direction, okay? Now, once they collide, they move in the opposite direction. Is that clear? Then what will happen to our equation? Let's represent this M1, U1, M2, U2. Then we have M1, M2, V1, V2. I hope this is clear. This is before collision, after collision. Okay? So M1, U1 plus M2, U2 will equal M1, V1 minus M2, V2. I hope this is clear to you. Recall that the first part is initial, the final part or the second part is final. Okay? Then the symbol represents the direction. So this is initial momentum. Then we have final momentum. Okay? Then we have before collision, after collision. Is that clear? Then we have the same direction. Then we have after or opposite direction. Opposite direction rather. Thank you very much. Connect to our social media handles at Physics Bible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped, stay liquid.